All right, hey guys, we are in chapter 5 now, and the reason that we are in a new chapter, or what is kind of the main theme to this chapter, is so far we've been looking at a lot of solving for one variable, solving for x. Well, now we're going to be looking at solving for two variables, x and y, and that's seen in solving a system of equations, and today we're focusing on linear, where x and y just are raised to the power of 1. Now, a lot of this is probably going to be a review for you. We're going to start by looking at solving a system of equations using substitution. And quick reminder for substitution, you want to isolate one variable and then plug it into the second equation. But before we do that, let's take a look at example 1. And what have we done in the past to eliminate fractions? Because I don't really like working with fractions. We can multiply both sides by the least common denominator. So that would be 15 in this case, between 3 and 5. And in doing that, I can just simplify this equation so it's easier to work with. So 3 goes into 15 5 times. So if I kind of move this over, that would be 5x plus 5 goes into 15 3 times, so 3 times 2y is equal to 4 times 15 is 60. And then this other equation, this looks pretty good. It's just x plus y equals 11. No weird fractions. But now in the process of substitution, you want to isolate one variable in one equation. So this equation looks pretty nice to work with. So I'm going to go ahead and I will take that equation and I will isolate y, sure. So I have y is equal to 11 minus x. And then I can take that value and substitute it in for y into the first equation. So I'll go ahead and take this first equation down here, which is 5x plus 6y equals 60. Take that value of 11 minus x and substitute it in for y, which would give me 5x plus 6 times, parentheses are important, quantity 11 minus x equals 60. Distribute that 6, giving me 5x plus 66 minus 6x equals 60. And combine like terms, 5x minus 6x is negative x. Subtract 66 to both sides, which would leave me with negative x is equal to negative 6. So obviously x is equal to 6. And once I have one variable, I can go ahead and plug it back in to solve for the other. So I have y is equal to 11 minus that value of 6. So obviously y is equal to 5. And now what's important to recognize is since we have two solutions, we have to actually think about this on a plane, the xy coordinate plane. Our solution is a point, 6, 5. When x is 6, y is 5, which means, so I can box that. But if I was to look at this graphically, what does this mean since I have two answers, not just one? That means that if I solved each of these equations for y and graphed their corresponding graph. So, I need that equation. So if I solve the first equation for y, then that was 5x plus 6y equals 60. So 6y equals negative 5x plus 60. Divide by 6. So y would equal negative 5, 6x plus 10. And then the second equation, which was y equals 11, or I'll just go ahead and rewrite that as negative x plus 11. That means if I graph these two on the xy coordinate plane, so thinking about graphing this one here, it would have a y-intercept for 5, 6, 7, 8, 9 of 10. Slope of negative 5 over 6. So I'd go down 1, 2, 3, 4, 5, right 6. And that would look like this equation, or this line here. And if I graphed this second equation, I'll go ahead and do it in that color. It would have a y-intercept of 11, and then the slope is a negative 1. So I would go down 1, right 1, down 1, right 1, down 1, right 1, and all the way until 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 5, it should, and I know that I don't have a straight edge with me on my surface, but we would see that they would intersect at the point 65. So that's what it would look like graphically. Okay, let's move on. I know a lot of this is a review for you, so let's move on to the process of elimination. Elimination, you do not isolate a variable. You're going to line up your variables and then multiply to eliminate. So let's use the same process that we did to start with for the previous problem. So we're going to get rid of our fractions, multiply both sides by the least common denominator. So we'll multiply this side, oops, not by 50, that's not the least common denominator. Multiply both sides by 10, and 5 goes into 10 2 times, so that would be 2 times x plus 6, plus 10 goes into itself 1 time, plus 2y minus x is equal to 10. Let's simplify this equation, which would give us 2x plus 12 plus 2y minus x equals 10. And 2x and negative x would leave me with x plus 2y. And I'm going to subtract 12 to the other side, because remember, with elimination, we want to line up our x's and our y's in both equations. So 10 minus 12 gives me negative 2. Now that equation is nice and pretty to work with. So let's take a look at the second equation, make that one nice and pretty. So we're going to multiply both sides by the least common denominator, which would be 20 in this case. Oops, I want a different color. Show you it's a different equation. So 4 goes into 25 times. So I have 5 times quantity, x plus 2, is equal to 5 goes into 24 times. Oops, not equals. Plus 4 times quantity, 3y plus 2, is equal to negative 60. So that gives me 5x plus 10 plus 12y plus 8 equals negative 60. We want to line up the x and the y in the same way the other equation is. So I have 5x plus 12y, and then 10 and 8 would make an 18. So if I subtract 18 to the other side, I have is equal to negative 78. Okay, now I have equation 1 and equation 2 nice and pretty, so I can go ahead and continue with the process of elimination. So I'm going to bring equation 1 and 2 off to the side here, which would be x plus 2y equals negative 2, and 5x plus 12y equals negative 78. Now, in the process of elimination, I'm going to go ahead and erase that 1 and 2 now, just so you know where that came from. We want to multiply one equation by a factor, which would allow us to, when adding, eliminate a variable. So I'm going to focus on the x's, and if I multiply this top equation by a negative 5, then when adding negative 5x to 5x, they will eliminate to 0. So in doing so, this would give me a negative 5x minus 10y equals positive 10. And I have that second equation, 5x plus 12y. Actually, I'll keep it in the same color that it was. You're probably like, Miss Prentice, you're so silly. You have colors all over the place, but yeah. So I have 5x plus 12y equals negative 78. And focusing on this, I now add straight down. Negative 5x plus 5x eliminates. Negative 10y plus 12y would give me negative 2y equals 10 plus negative 78 is negative 68. Divide by negative 2. And I should see that y is equal to 34. Now, after I have y, I can plug it into any of the other equations to go ahead and solve for x. So I'll go ahead and plug it into my equation 1, which is up here. So my equation 1, which was x plus 2y equals negative 2. Plug in that y value of 34. And that leaves me with x plus 2 times 34 equals negative 2. So that gives me x plus 68 equals negative 2. Subtract 68, and I'll have that x is equal to... oh shucks, Shuckamucks. I think I made a mistake somewhere. Where did I make a mistake? Negative 5x minus 10y equals 10. 5x plus 12y equals negative 78. And that would give me, oh goodness, you guys are thinking, Miss Prempis, negative 10y plus 12y is equal to a positive 2y. Don't work too fast in the morning. So when we divide by a positive 2, yes, we should get y is equal to negative 34. It's a good thing I worked these notes out before I did the video, so I know the correct answers. Sorry, guys. So that would give us a negative 68. So when we add 68 to the other side, then it gives us a positive 66. So our correct answer is 66, negative 34. And again, what that means graphically is if we graphed both of these equations, that would be our point of intersection. We can also check our answers, and to check, we would plug in both answers into, so both x and y into both equations, and it would have to show both true. So just a quick reminder for the check step, x and y have to make both equations true. Both equations true. Okay, I'm going to go ahead and pause the video. You work out example 3 based off of your method of preference, and then we'll go ahead and see just kind of how we did here. Please tell me that I've been recording. Oh, good, I have. Okay, guys, go ahead and check that you got the answer of 3-1. You could have solved using elimination or substitution. Looking at my method here, I obviously used elimination. Okay, let's keep moving on here. So next piece is solve the following. After you solve, isolate y in each equation and sketch the graphs using your calculator. Make some conclusions based on your results. Okay, looking at this equation, the first thing that I would look at solving is probably elimination, since the variables are already lined up. And even if I focus on x, if I just multiply this equation by 2, that would give me a 6x minus 4y is equal to 8. And if I add that to the bottom equation, negative 6x plus 4y is equal to 7, I get 0 plus 0 equals 15. 0 equals 15? What? That's how my 2-year-old, he'll say, what? What? It's not possible. 0 does not equal 15. So now the next step said isolate y in each equation and sketch the graphs. So if I isolated y, we'll take this first equation here. That would be negative 2y equals negative 3x plus 4. Divide by negative 2, so I have y is equal to 3/2 x minus 2. And if I isolate this y here, that would give me 4y is equal to 7 plus 6x. Divide by 4, so y is equal to, and if I just put x first, that would be a 3/2 x plus 7/4. Now what you're going to notice here is that this 3/2 and this 3/2 is the same slope. You might remember from geometry that equations with the same slope, or even from college algebra actually, same slope have parallel lines. And furthermore, since these y-intercepts are different, we know that we're going to have a graph that they are going to indeed be parallel. So this one's at negative 2, and I go up 3, right 2. This next one, 7/4, that's, what is that? That is 1.75. So we're going up to 1.75, and then up 3/2. 1, 2, 3, right 2. I'm going to get parallel lines. So what does that mean? That means that these two lines will never touch. They have no solution. So if you end with false statement, the lines, since we're working with linear equations, will never touch. Therefore, the answer is no solution. because there's no answer for x and y that satisfies both equations. Looking at the next one, it's a similar type scenario. We can solve using elimination, so multiply both sides by -2, which would give me -4x minus 6y is equal to -12. And I have 4x plus 6y equals 12. When I add, I get 0 equals 0. Again, what? What does that mean? Well, 0 equals 0, that is true, but what does that mean about these equations? Well, when we solve these equations for y and we plot both equations, we're going to find something quite nice. But I need to pause the video because I need to plug in my computer and then we'll go ahead and finish. Okay, if we isolate y for each of these equations, we're going to find that the same equation comes about. It becomes -2/3 x plus 2. So when I graph both of those, they are going to have a -2/3 slope. They are both going to be the exact same line. So what does that mean? That means if the equation is true, then there are infinite points of intersection. So there are technically infinite solutions, but we can't just say -infinity to infinity because they are solutions that match this specific line. So down here below, I have how to answer each of these questions. So if there are an infinite number of solutions to an equation, does that mean any ordered pair you can think of is a solution to that set of equations? No. So how would we write this solution as an ordered pair? Well, it would be whatever x satisfies the output that we found. So it would be whatever x is -2/3 x plus 2 would give you the y. Okay, so why don't you try the last one on your own, and then I'll show the answer and you can check it. Okay, so as you can see, we ended up with a true statement. 0 does equal 0. Therefore, this system has many solutions, but the specific solutions are all x that would fit into this output. So we did have to take the equation, solve for y to determine what the line was, and this would tell us our output value. So if you got this, awesome.